All right, so now with our graphing technique, okay, I'm going to teach you a method today that'll hopefully help you really simplify graphs, okay? Because for the most part, when you're doing it without a calculator, what do you have to do? Plot points, right? Plug points in for x, and then figure out what y is, and okay? With certain types of graphs, I'm going to show you, especially with quadratics here, with parabolas that we're talking about, I'm going to show you a method that I think is going to be a lot easier for you. And that it'll help you graph these things, especially by hand, a lot quicker and with way fewer mistakes than you normally would. Okay. All right. So I'm gonna let's blow this up a little bit, and then here we go. Okay. Now I know you can't see it on my screen, but look at that box on the right, and we're gonna kind of go through the directions here. Okay. So the first thing we're gonna do is we're gonna plot the origin right here. Okay, so then we know the or plot the vertex, sorry, at the origin. Yeah. See, when you're brilliant like this, you're always thinking 2 or 3 steps ahead, so not really. That was not a true statement. Okay, moving on. Man, I can't get a rise out of you guys for nothing. All right, so if we know that it's an x squared term, okay, if fx equals x squared, then what we're going to do is we're going to move one point to the right, and we're going to move up 1 squared, because my x term is squared. So we go to right there. Then from the vertex, I'm going to move 2 to the right, and then I'm going to move up 2 squared, which is 4. There's my point. Then I'm going to go left 1 and up 1 squared, and left 2 and up 2 squared. And there's my parabola. Okay. So now, the key to this method of graphing, though, is you have to know where the vertex is, right? And we're going to talk about that and show you how to make sure you know exactly where the vertex is. We're going to establish some transformation rules and things like that, so we can always find that vertex, all right? Okay, so now we can change the function so it still has the basic same shape, okay? But we've moved it a little bit. So what is this plus 1 going to do to my function? It's going to shift it how? Up, down, left, right. What do you think? Okay, yeah, it's going to shift it up, right? Anytime there's a constant added to the very end, it's what we call a vertical shift. So if it's positive, it's going to shift it up. If it's negative, it's going to shift it down. Okay? So now, where's my vertex going to be here? At 0 and 1. Good. Now, those same graphing technique rules apply. So from the vertex, I go right 1 and up 1 squared. I go right 2 and I go up 2 squared. Left 1, up 1 squared. Left 2, up 2 squared. And there's my vertex, okay? Or my parabola. So what about x squared minus 3? How's that going to shift it? Down 3, right? So my vertex is at 0 and negative 3. So here's my vertex right here. Oops, I gotta go straight up and down. Here's my vertex. Same techniques apply. Right 1, up 1 squared. Right 2, up 2 squared. Left 1, up 1 squared. Left 2, up 2 squared. And it always works. Now let's fill in our box here. So if you take f of x plus k, we move the pattern. If we add k, we move it up. If we subtract it, we move it down. And again, this is called a vertical shift. So what happens if we add 1 to the inside? Okay, if to the outside, it's a vertical shift, guess what the inside is going to be? A horizontal shift. Okay, so what's that plus 1 going to do for me? Shift it left or right? Okay, left. The consensus is left, and the consensus is correct. That is a left shift. So we shifted left 1. So now our vertex is at negative 1 and 0. And apply our techniques. Right 1, up 1 squared. Right 2, up 2 squared. Left 1, up 1 squared, and left 2, up 2 squared. Okay, so x minus 3 quantity squared is going to shift it to the right. So 1, 2, 3. There's our vertex at 3 and 0. And now we're ready. Right 1 up 1 squared, right 2 up 2 squared. We get the gist, right? Left 1 up 1 squared, left 2 up 2 squared. And there we go. All right, so if we have f of x plus h, we move the pattern. If we add it, we move it to the left k units. And if we subtract it, we move it to the right k units. And that is called a horizontal shift. Okay, so what's this negative sign out front going to do? It's going to flip it, right? Over the x-axis. It's going to make all my positives negative, okay? So, where's my vertex here? 0, 0, right? I plug 0 in for x, and I get 0 for y. Now, same techniques apply, but instead of going up, we go down. So, right 1, down 1 squared. Right 2, down 2 squared. Left 1, down 1 squared. Left 2, down 2 squared. And there's your graph. Okay. So again, so that is a vertical flip. If there's a negative out in front, it flips it vertically, okay, across the x-axis. Okay, so if we stick a number out in front, all right, what's that going to do? Oh, wait, the answer's right there, okay? It's going to be a stretch or a shrink, depending on what that number out in front, which we call a, okay? So if it's 2x squared, okay, let's graph it. So where's my vertex? Vertex at the origin still, right? That one doesn't change. Now, if x is 1, what's y? 2. If x is 2, what's y? 8, okay? So we know that, but now let's tweak our graphing technique so we don't have to plug that in, okay? So if I go right 1, I go up 1 squared times 2. Or I go up 2, so right 1 and up 2. If I go right 2, I go up 2 squared times 2, or 8. So again, left 1 up 2 squared, or 1 squared times 2. Left 2 up 2 squared times 2. Okay. So we can see it takes that x squared and just, now it's called a stretch because you're thinking about just taking the graph and just doing this and stretching it, it's going to make it skinnier, right? So like me, if you took me, I'm roughly 6 feet tall. Okay, if you stretched me out to 7'3", I'd be a whole lot skinnier. Wonder if we can do that. Okay. All right, so it's the same concept here. Take the graph, grab it, stretch it, makes it skinnier. So it's called a vertical stretch. All right. Now, let's look at 1/4 x squared. Okay, so vertex is still at the origin. Now if I go right 1, I go up, how much? 1 squared times 1/4, or I go up 1/4. If I go right 2, I go up how much? 2 squared times 1/4. What's 2 squared? 4 times 1/4? 1. I go up 1. I didn't plot that first point very well at all, did I? I should have this up a lot bigger than it is. That's my problem. Oh, gosh, I did it again. You have to trust me on this one. So then I go left 1, up 1/4, left 2, up 1. And so you can see it squishes it or flattens it out, right? Take Stockton. How tall are you, Stockton? Liar, you're not that tall. Okay, squish him down to 5'2". He would actually show up if he turned sideways, right? Because right now he turns sideways, he just disappears because he's so freaking skinny. Okay, so that's how that works. Okay, all right, we're good. There we go. After it creates a shape, okay, then the graph is changed in the vertical direction. okay? And if a vertical change does exactly what we think it would. Adding moves it up, okay, subtracting moves it down, multiplying, bigger than 1 stretches it, etc., etc., okay? Okay, so let's just quickly, all right, I don't even think we really need to graph those because we get it. All right, so what is the graph on the left going to do? Shift it up 2, right? The second one, down 1. What's 3x squared what's that 3 going to do? It's going to and you say it this way, it's going to stretch it vertically by a factor of 3. That's how you would say that. Okay? And then what about negative 2x squared? What's that going to do? It's going to flip it and stretch it by a factor of 2. Okay? So on this one, so I do want to graph that one on the far right. So again, vertex at the origin. That's not nearly big enough. And then we go right 1 and down 1 squared times 2. Yeah, I can't. Hang on. Come on. This program is so weird sometimes. Okay, so go right 1 and down 1 squared times 2. Right 2 down 2 squared times 2, which is 8. And then left 1, down 2, left 2, down 8. And there we go. Okay, that's what our 2x squared looks like. That's kind of sideways. Sorry about that. Okay? If there's anything on the outside of that square, okay, of that x squared, so we add it to the end, we multiply it out front, okay, anything that's on the outside affects our graph vertically, okay? Anything on the inside, okay, inside the x squared affects our graph horizontally, okay? That's basically what we're saying here, okay? So that x minus 3 squared, what does that do? Shifts it which way? To the right. X plus 4 squared shifts it to the left, okay? All right. Now we're going to put these transformations together, okay? So we find our vertex first, and then we're going to shift it, or stretch it, or plot our points, okay? So in this case, where in this problem here, where's our vertex? How is this shifted? It's shifted to the left 1 and down 4. So where's our vertex then? At negative 1, negative 4. Okay? Does everybody understand that? Okay? Because that's huge. Are we good? Okay. So negative 1, negative 4. That's our vertex. Now, with our equation, we don't even need those numbers anymore. The only reason those two numbers exist is to tell us how to shift it. Okay, now we use our same techniques using y equals 2x squared. Okay, so from the vertex, I go right 1 and up 1 squared times 2. I go right 2 and up 2 squared times 2, or I go up 8 from that point. And then I go same thing on the left. Left 1 up 1 squared times 2. Left 2 up 2 squared times 2. And there's your graph. See, and this is where this method gets so much easier than just plotting points, right? Finding your vertex, and then, okay, if x is 1, y is this. If x is negative 2, y is this. Then you're going to plug all that crap in and figure it out. Much greater cause, or much greater chance for error, okay? Okay, so even something messy like this ain't no thing, okay? All right, so how is this one shifted? To the left 3 and up 2. So where's my vertex? Vertex is at negative 3 and 2. That really does say negative 3, I promise. Okay, so there's our vertex. All right, those are done. We don't need those anymore. Okay? So I'm going to just go right 1, and where am I going? Down how much? Down 1/2. So we go right 1, down 1/2. If I go right 2, I go down 2, right? 2 squared, which is 4, times 1/2 is 2. So I go right 2 and down 2. Then I go left 1 and down a half, and left 2 and down 2. And there's my graph. Okay. Now, if it asks for the specific points, those are pretty, you can plot those pretty easily, right? Because when you go right 1, so if our vertex is at negative 3, 2, I go right 1, my x value is negative 2. And then I know I'm going down a half, so I'm at 1.5 or 3 halves, however you want to write that. If I go right 2, I'm at negative 1, and then I know I'm going down 2, so I'm at 0. Then I go left 1, I'm at negative 4, and then we know we're going down 1. And then left 2, I'm at negative 5, and we're going down 2. Boom. You can plot those points that fast. Okay? Because all you have to do is be able to count. If you can count, you're golden. Okay? How are we doing? We all right? I know you guys are a bit on the quiet side, but because it's early, and believe me, if I were sitting where you were, I'd be quiet too. Okay? Were we okay? Questions? All right, a couple other changes that we talked about that are kind of hard to just see. See, so let's look at it. All right, so okay, we all know what the square root function looks like, right? Y equals the square root of x. Okay, it looks something like this, give or take, right? Okay, so what is that? What do you think that negative inside is going to do? Okay, yeah, it's inside. So it's going to be a horizontal change. Now, on the outside, a negative flips it over the x-axis. So on the inside, a negative is going to flip it over the y-axis. Okay? So, start the origin here. X is 0, y is 0. If x is negative 1, what's the square root? Okay, then that negative right here is going to change it to positive. Okay? So, the square root of 1 is 1. X is negative 4, then y is 2. Okay. So yes, it just flips it over the y-axis. Okay. All right. Now the 2 inside. What's that going to do? Okay. Well, let's plot a few points and see. Okay. So we know 0, 0. All right. That one's obvious. Now, let's be smart about picking our x's. Let's say x is 2. What's y? Yeah, y is going to be 2 as well, correct? Because 2 times 2 is 4, and the square root of 4 is 2. Okay? All right. So what does that do to it? Yeah, it just kind of, it stretches it, okay? All right. So, bless you. All right, so let's look at the 1/4 now. So again, we're at 0, 0. All right, now we can do x is 1 here. Okay, so what's the square root of 1 over 4? 1 half, right? Square root of 1 is 1, square root of 4 is 2. So we're at 1 and 1 half. Okay? What if we made x 4? Then it would be 1, correct? Okay. All right, so now, but remember, these are on the inside, so these are horizontal effects that we're having on it, right? So the square root of 2x is actually a horizontal. What do you think? It's actually a horizontal squish, right? Because it's going to take that thing, you're going to squish it, and it's going to whoop. Okay? And then a horizontal stretch is going to flatten it out. Okay? So again, anything that happens horizontally is opposite of what you would think normally. Okay? Or it's opposite of the vertical stuff. Because vertical, if it's a 2, it's a stretch. Okay? But horizontally, okay, if it's inside, if it's a 2, that's going to squish it. All right, so if y equals f of negative x, okay, then the graph is flipped horizontal, or horizontally flipped, if you want to say it that way. Horizontally flipped across the y-axis. Okay. And if we have y equals f of a times x, then the graph is horizontally stretched or shrunk. Shrunk if it's greater than 1, stretched if it's between 0 and 1. Okay, so now we remember what the absolute value looks like, right? Because we hit those parent graphs last time. Okay, so what's that plus 2 going to do? Shift it up 2. Yeah, the rules apply to every kind of function, whether it's a quadratic, whether it's an absolute value, square root, whatever, doesn't matter. Okay, so our vertex is at 0 and 2. Then I go right 1 and I go up 1. I go right 2 and I go up 2. Don't complicate this, people. Left 1, up 1, left 2, up 2. Okay. All right, next one. Y equals the absolute value of 3 times the absolute value of x plus 2 minus 1. So where is our vertex? How is this shifted? Our vertex is at where? -2, -1. Correct. Okay. -2, -1. There's our vertex. Okay. Now I go right 1. And do I go up or down? Up. How much? 3, right? 1 times 3. We got to times it by that coefficient out in front. So right 1 and up 3. If I go right 2, how much do I go up? 6. And then left 1 and up 3, and left 2 and up 6. So again, notice that 3 just stretches that thing out. Okay? All right, next 2. Okay? So where's my starting point here? It's shifted at, which way is it shifted? To the left 1, right? So we're right here at -1 and 0. Okay? All right, so now, once we've shifted it, that's done. So what's that -4 going to do? It's going to flip it and stretch it. Correct. Okay? So now, but with square roots, I'll tell you, and this is just between you and me, all right? Square roots, you're probably better plotting a couple of points. Okay? That's probably the only one I'll say that with. But square roots can get a little goofy, so it's not a bad idea just to plot a couple points, but pick some smart points, okay? So for example, I'm going to pick, wait, okay, I can't erase that, I don't want to erase that, okay. So I'm going to pick x as 0. Okay, so if x is 0, what's y going to be? -4, right? Because 0 plus 1 is 1, square root of 1 is 1. -4 times 1 is -4. Okay, now I'm going to pick x as 3. So if x is 3, what's y? All right, 3 plus 1 is 4. Square root of 4, 2. 4 times 2, -6. 8. Did I say 6? I said 8. I said that, I'm like, okay, no, didn't sound right. -8. -3, -8. And there's our graph. So notice it flips it over the x-axis, and then that really stretches it out. Okay? Okay, now this one is a cube function. Well, let's apply our rules. Okay? Where's my where's my starting point? You can't say it's a vertex here. But where are we shifted? To the right 1 and up 2. So we're going to start, instead of 0, 0, we're going to start at 1 and 2. Okay? Now I go right 1 and then I go up. Okay, again, these two are gone now. We don't need them. I go up 1 cubed, which is still 1. I go right 2, I go up 2 cubed, which is 8. Good. So that's right up in here somewhere. I go left 1. But now here's the deal though, okay, with cube functions, right? So now when I go left, I'm not going to go up because it's a negative, correct? So if I go left 1, it's like going left -1. So what's -1 cubed? -1, right? So I'm going to go left 1 and down 1. I'm going to go left 2 and down 2 cubed is 8. Yeah. So my graph looks like this. Okay. Now, does that make sense with cubes? Okay. Squares, because when you square anything, it's always positive. So you're either going all up or all down. But when it's cubes, when you go to the in the negative direction, okay, when you cube a negative number, it stays negative. Okay. So if I'm going left 1, that's like I'm making x the -1, if you will. So I'm going to go down -1 cubed. And then if I go left 2, then I'm going down 2 cubed, or -2 cubed, or 8. Okay. Okay, so the first thing that you want to do is shift it. Okay, if there's pluses and minuses in there, right, you want to shift it and find that vertex or find that starting point. Okay, then you kind of move left to right. Okay, so there's a flip it, and then stretch it at that point. Okay, shift it first, then flip and stretch. Okay, good question. All right. Okay, so now look at example 9. You're going to have some problems like this on your assignment. So when we write an equation for y = x cubed, if it's been vertically stretched by a factor of 4 and moved right 5. Okay, so what are those things going to do to my equation now? So we get y equals, okay, if it's vertically stretched by a factor of 4, where does that 4 go? Outside the parentheses in front, right? It's not a plus or minus, it's a stretch. So a 4 goes out here. Okay, now if we move it right 5, where does that 5 go? Inside parentheses, and it is a -5. There you go. Vertically stretched by a factor of 4 and moved to the right 5. That's what that looks like. Okay. Questions about that? We all right? Okay. Now, whoa, what are we going to do? Okay. 1 over -x plus 2. Okay. What do you think? Okay, but what does 1 over -x look like? What does 1 over x look like? Remember? Okay, so 1 over x, remember, looks like this. Okay, so we're going to flip it over. Actually, we're going to shift it up 2, and then we're going to flip it. Now I'm wondering. Okay, so to do this now, what we need to do, we need to amend that. We've got to flip it first, okay? Then we shift and stretch and shrink at that point, okay? So to graph this one, okay, the first thing we're going to do is we are going to flip it over the x-axis. Okay, so instead of looking like this, all right, now if without that plus 2, so y equals 1 over -x is going to look like this. Okay, now we're going to take that whole mess and we're going to shift it up 2. Okay, so that's going to look like this. So now our new asymptote, instead of being at the x-axis, is going to be at x equals 2. Okay. And then again, now the vertical asymptote stays the same because we're not shifting it left and right. We're only shifting it up, and then it looks like this. Okay. Good. You okay? Let's talk about the transformations of each of these, okay? So this is, and you'll have problems like this. So you'll just be given some function, okay, it looks like that, and then you're going to be asked to do that to it. So what is that plus 2 going to do to our graph again? Shift it to the left, correct? So now what does that mean with specific points here? If I shift them all to the left, basically what am I doing? I'm subtracting 2 from my x values, right? So instead of -4, -2, it becomes -6, -2. Instead of -2, -2, it's -4, -2. Instead of 2 and 2, it's 0 and 2. Instead of 4, -2, it's 2, -2. Okay, does that make sense, everybody? And this is what I'm getting at with this problem right here. Okay, I want you to think, okay, to actual points, what is this going to do to that point? Okay? All right, so negative f of x. So what does that negative do? It flips it over the x-axis. So what does that do to points? Okay, so it makes your y value, does it affect your x or your y's, first of all? It affects your y's, correct? Because it's a vertical flip. So what does it do to your y's? It changes their signs, right? So we go from 4, -2 to 4, +2. We'll graph this one. We go from 2 and 2 to 2 and -2. We go from -2, -2 to -2 and 2. And we go from -4 and -2 to -4 and +2. So now it looks like this. Right? So truly, we just flipped it over the y-axis. So a negative sign changes the sign of your y's. Okay, jot that down. So if it's added on to the inside, okay, you add or subtract from the x. If there's a negative on the outside, if we don't flip it over the x-axis, it changes the sign of your y's. Okay. All right. Now this says 1/2 f of x. Okay. So what's that? So what's that 1/2 out in front going to do? It's going to squish it, right? So it's a vertical change. So what's it going to? Is it going to affect x or y? It's going to affect our y values. And how's it going to affect them? It's going to cut them all in half. Exactly right. Okay. So instead of -4, -2, we get -4, -1. Instead of -2, -2, we get -2, -1. Instead of 2 and 2, we get 2 and 1, and instead of 4, -2, we get 4, -1. So there's our graph. Again, wow. It's just taken it and just squished it down. Okay. All right, part F here, that negative on the inside. What's that going to do to it? Flip it over the y-axis, correct? So if we flip over the x-axis on part C changes the sign of our y's, guess what a flip over the y-axis is going to do? Change the sign of our x's. Okay? So this becomes, instead of -4, 2, it becomes +4, -2. Instead of -2, -2, we get +2 and -2. Instead of 2 and 2, we get -2 and 2. And instead of 4, -2, we get -4 and -2. Whoops. Right there. So there's that graph, okay? Or again, we flipped it over the y-axis. All right, now what about a 2 on the inside here? What's that going to do? Look back at your other notes if you need to. So if it's a stretch or a shrink, it's on the inside, A is bigger than 1. What's it going to do? Is it going to stretch it or is it going to squish it? On the inside. It's going to squish it, right? Remember, horizontally is always opposite of what you think. So it's going to squish it down, okay? So does that affect our x's or our y's? That affects our x's, right? And it's actually going to cut them in half. Again, opposite of what you think. Okay? So instead of -4, -2, I get -2, -2. Instead of -2, -2, I get -1, -2. And instead of 2, 2, I get 1 and 2. And instead of 4, -2, I get 2, -2. So it's here, here, and here. So we've squished it in. Okay. Again, outside the parentheses, vertical shift. Inside, horizontal shift, opposite of what you think.